Good morning all, how are you? So I want to do some stuff with this thing today. I put the second board on, which has power delivery, a USB Type-C socket. I had to mount this one slightly oddly, so I've mounted it vertically up that way, because when you press this switch, what is there? The lights that tell you how much charge there is in here are on the bottom of the board, which is slightly odd, but there they are. So that's saying 3 out of 4. Interestingly, this one says 2 out of 4. They slightly disagree, but never mind. And I get the impression that these are not Coulomb counting indicators, so they're just giving a state of charge based on the voltage across the cells. So let's just have a quick look at the PD functionality of this second board. We looked at this one in a previous video. This is the W332 chip board. This is the SW6106. I think it's that. Should we have a look? So this one, W332, check. This one, oh, focus. This one, SW6106. Now, some helpful people, thank you very much for that. Last time gave me some information on how to find a datasheet for the W332. I'll link to that in the description below because that was very useful. It's in Chinese, but if you translate it, you do get information on what the functionality of this switch is. And there is a 10-second reset thing. Press and hold it in for 10 seconds. It does a full system reboot. This one doesn't appear to have that, but the switch does do stuff. But I just wanted to check out the PD functionality. So briefly, let's plug in the PD trigger into the W332 board. Now I've set the PD trigger so that it boots, or it immediately... Oh, why is that flashing? That's curious. I've never seen that. Why is it flashing? Is it saying low power? Anyway, it boots up and asks for 12 volts immediately. That, why is that flashing? Oh, it's saying it can't have... I think that's saying... Because the green light's gone off here. So is that saying, I'm not getting the higher voltage thing? Let's try it on the other board. So on this one, I'll plug it in. This goes green, which says I'm asking for 12 volts. And there are two green LEDs either side of the switch. It's really weird because one's on one side of the board, the other one's on the bottom of the board. So I don't quite know what the topology of this power bank was intended to be, but yeah, with the state of charge indicator on the bottom, it's all a bit strange. These two LEDs do appear to be in parallel, or series or whatever, but they come on together. So that's interesting. I've got a feeling you can get out of... Yes, you can. You can get out of high voltage mode. Immediately, the green LEDs here go off. This goes red, which means it's all gone back to 5 volts. But what is this rather queer, this thing flashing that funny light, which actually was teal. Now, teal is not 9 volts. Teal, if it's on constantly, is actually 15 volts. So what was going on there? Perhaps if I do a full system reboot, press and hold for a full 10 seconds. See what happens. Oh, there it is, gone funny again. Right, that's done a full system reboot. That's asking for 12 volts. That's got its green LED on. It's hard to see. Oh, very hard to see actually. But it is on, I can assure you. Actually, can we see that through the magnifying glass? Well, you can see that there are two LEDs on. You can't see the colour there, which is really weird. But LED 5 is most definitely green. I suppose when they're this close, they just bleach out to white, don't they? And of course, this isn't drawing enough power for this board to think it's got a load connected. So let's shove this 24 volt bulb into these holes. Doesn't need to be 24 volts, but actually it's useful for when you're putting this on a PD power bank which goes up to 20 volts. Okay, if I switch that on, what happens? That's asking for 12 volts. Oh, it doesn't appear to have got it. No. Something very strange going on with this board. What if I request different voltages? No, nothing. What's going on there then? Let's unplug this, plug it back in. That asks for 12 volts, but it's not getting it. Why is it not getting it? Have we got a dodgy connection on these Type-C connectors? They look dodgy. Yeah. So maybe that means I'm asking for 12 volts, but I'm just not getting it. I wonder why that would be. Oh, I just did a reboot on that switch, held it for 10 seconds. I'm definitely getting 12 volts now, because that light's a lot brighter. That's definitely 12 volts. This is saying 12 volts, and the green LED is on down here. But yeah, some funny business going on with this one. Well, I'll keep an eye on it. That's really why I've put both of these on here, so I can play around and experiment. But actually today what I wanted to do was something different. I want to just add some more cells, and I've decided to make this thing look even weirder than it does already. I'm going to put another block of 4 up there on top, so it's a sort of curious L-shaped contraption. So for this stage I shall need these. These are spare lithium-ion batteries from Wix. They had their own branded power tool, 12 volt power tool, and they obviously decided to abandon that. Either it wasn't selling very well, or there was no profit in it. And so they sold off these 12 volt batteries and the 20 volt batteries, although I didn't get many of those, I only got 2, for £1 each. So I got 3 cells in there for £1. They're not hugely high capacity cells, they're actually 1.3 amp hours only, but let's get these things apart and rip some cells out of them. Now, you can get these battery packs reasonably cheaply. Lidl have a range of 12 volt power tools, and I think the batteries go for £8. So you can get 3 cells for £8. I don't know whether they're 1.3 amp hours, they might be 1.5. I can't remember, but yeah, if ever a company is selling off their spare battery packs for £1 each, well, you drive around all the local stores and pick up as many as you can. Right, let's take a look in here. So yeah, there's a little circuit board, and then that pulls out, and there are my 3 cells. So first thing I've got to do is cut all these wires. So, which wire do I cut? Red or green? I don't think it really matters. So let's snip that, snip the white one, snip the black one. Oh, that fell off. There's the temperature switch, I believe that is. I believe it's actually, well, possibly a bimetallic strip. Yellow, so that comes away if I cut that white wire. And there are my cells. So now, because I'm going to use the Vrusen end caps, I'm actually going to have to try and rip, by sort of twisting this welded nickel strip off these cells and try to get them as flat as possible. Okay, let's start with this one with this white wire on this negative end. Now I did this once before and I didn't make my shear force sideways enough. It actually was quite a lot away from the cell, and it kind of pulled the bottom of the cell and bulged it out slightly, which I didn't like particularly because I don't know what's going on actually inside the can. So with this one I want to sort of roll it so that the force is mostly to the side, so that I'm not forcing the bottom of the cell to come out in a dome shape. So that's fine. Then you've got these little pips which remain on there, so I'll just take the worst of those off with my flush cutters. I shan't bother to sand them down. I mean, I'm never going to be pulling massive currents from these things, so it doesn't really matter if all the current goes through one of these tiny little spikes. It'll be fine. Right, this one I think I might be able to do like so. Oh no, that's putting quite a outward force on the cap of that one, so I might cut them in half and do the rolling thing again. Yeah, let's cut through there. How soft is that? It does seem quite soft. And break that. I don't think I actually cut through that at all, did I really? Now I have, and then I will roll it off with my pliers. Oh, they're a bit wedged into that thing. So rolling this off so that all my forces are as lateral as they can be. Ooh, something moved then. Don't know whether the cap moved relative to the... Nah, it must have just been the pliers. Anyway, I shall plough on with this section of video to be speeded up in post, because nobody wants to watch this in real time, do they? No, they don't. Okay, so that's 3 cells. Now, of course, in order to make another block of 4 on here, clearly I need more than 3 cells. So I'm going to open another one of these, and then I'll put the 2 spares into... This was actually a fishing tackle box, but it makes quite a nice... That's too low. Quite a nice storage case for all my different lithium cells. Right, there are my 4 cells. I think they're cleaned up well enough. A little bit wobbly because they do have little pips sticking out the bottom. Now I need some Vruzend. This box is called Ruzen, but if you put a V on the front and a D on the end, you get Vruzend. So let's see what we've got in here. These are the bags of the nickel strips, the bridging strips, the barrel bolts that run through the centre, and all the nuts. There's another bag there. Oh, there's my modified saw blade, so that you can hold one of the bolts still while you tighten the other one up. Excellent stuff. And I need some of these caps, 4 blues, 4 reds. Now I worked out a sequence for doing this, and I can't remember what it is, so I think perhaps I'll just copy this. I'm going to have slots top and slots right, but on blue I want dovetails top and dovetails right. So let's see if I can... Now of course all the reds are going on one side, so that looks correct. It'll be slots top, slots right. So let's do that now. Slots top, slots right. Slide these 2 together, and then they look like they slide like that. Yeah. So that's it. So that block I'm making as a mirror of this block. That's good. Now let's do the blues. They are dovetails top, dovetails right. So dovetails top, dovetails right. So those 2 slide like that. Similarly for these, dovetails top, dovetails right. Why won't that go in? It will. And then I've got to get that to fit in there. Yes. So that's That's the blues on that end. Okay, let's get my cells in. Right, positive side to red in all 4 cases. Positive side to red. Yeah, that one's okay. And then blues. Now I've got to keep everything in sync. So dovetails top and right. These are slots top and right. Okay, so that will sit on there because I want this curious L-shaped design. But first I need to put the barrel bolt down through the center of this pack. So we pass one end of that rod down through the middle, make sure it comes out here, which it has. Put the bolt in there, and you can tighten this as much as you want, and all that happens is the screw on the other side, or the bolt on the other side, rotates once you get any force on this thing, which is why I came up with the idea, yeah, that's rotating now, why I came up with the idea of this saw blade. So let's just line that up so that it's square, place that across there, and then I can hold that. Yes, it hurts a bit, but that's not a problem. And I think I did like 8 turns or something like that. Yeah, that's tightening up quite tight. Then the next thing to do is to just check whether they're approximately the same length. Oh no, that's a bit longer, isn't it? Yeah, so I think I'll just do that up a little bit tighter. Put my saw blade back on. Another couple of turns. Let's try that. How good is that lengthwise? Oh, it's pretty close. So yeah, I'm going to shove that on the top now. Now that, because I've done dovetails one end and slots the other, that should just slide on now. Oh, it's a bit tight to that thing, but that's okay. I don't mind that. And it's gone on. There it is. That's looking good. Fantastic. So all that needs to be done now is just put a plethora of these things on, bridge across. Doesn't matter whether it's 2 bridges or 1 bridge. Never going to pull much power out of this thing. Yeah, get all the nickel strips on, bridge across. Now there's just one thing. I'll just check. These cells that came out of the Wix batteries which have been sat about for donkey's years, a year perhaps, are probably at about 3.7, and I think I brought my main pack down to about 3.7, but I'll just now check. Okay, main pack is, yeah, 3.7. Let's just take a look at one of these, because I haven't bridged them all together yet. Okay, they're a little bit higher, 3.8, but it's not going to be a problem. Let's get the nickel strips on. Right, don't need to... Oh, that's gone a bit wonky. Don't need to think too hard about this, because it's all positives on this side. But I'll follow the pattern I did on that one. 2 going that way. Oh, that's a bit bent, that one. 2 going that way. And then I need a bridging piece. Oh, I'll need to undo that nut. So I'll probably bridge across there. That'll do. So I need some nuts. I think these are M3s. Pretty sure they're M3s. So let's get some of those on. This is the fiddliest bit. It really is. And having a little nut spinner. This is 5.5mm for the across flats on the 3mm, the M3 nuts. Having one of these makes it so much easier. Otherwise it's just really fiddly and takes all day. So now the bit that oh no, it won't matter if I'm just connecting posies. It will be, yeah, that's a problem if you've got positives and negatives all sort of next to each other and you drop this thing across 2 connections. You want to be more careful if you're bridging a pos to a neg, because you don't know what you're bridging. But here it's all pos, so it doesn't really matter. Shove these nuts on. No, that never seems to work. You've got to get this nut on flat to start with, which is fiddly. And then once it's flat on there, you can do it up. Oh, that's a bit... Thread feels a bit tight. There are probably imperfections in these threads. Do it up with that nut spinner. So just finishing up the positive side, tighten these nuts onto the Vrusen studs, these bolt studs which are welded, I think, onto the sort of bendy caps that press against the battery end. It's so much easier than welding or soldering, and what I like about this is if you think, actually I don't like L-shaped battery packs, you can just take it all apart and make another design. I didn't actually tighten that quite as tight as these ones because there is a bit of a step there. I'm not too worried. I like imperfections. Okay, so let's link those and then across for those 4 batteries. Now, I mean, all those 4 cells are all going to be slightly different voltages, so just doing this has brought them all to the same, and you're not going to get a problem with rushes of current unless you've got some cells that are completely empty and others that are completely full. And even then, I don't think that you would have a major issue, because it's very easy to lift the voltage of a low voltage cell up and pull the voltage of a high voltage cell down. Right, across there, yeah, no problems. Let's get these nuts on. And my new larger capacity, oh, what will it be? It'll be 3/8 no, 3/4 are 12 times 1.3 amp hours. What's 12 times 13? 12 12s are 144, so another 12 is 156, is it? So this will be a 15.6 amp hour battery, or a 15,600 milliamp hour battery, 15,600. Now that never works. You can't put the nut in the spinner. You've got to put the nut on top of the stud and then spin it down. Yeah, so 15,000 milliamp hours, or 15.6 thousand, in quite a large form factor. It is quite large, isn't it? I suppose I could push these buttons and just make sure my lights still come on. Yeah, still saying 3 there and 2 there. Fabulous. Yeah, because these cells are such low capacity cells, I mean, in the modern power banks we're buying now, you're probably getting cells which are 3, 4, or even 3,600 milliamp hours. I could put another strip across there, but I don't want to, because I haven't there, and I'm not going to there. And you know, this one strip will be easily enough for the sort of currents I'm going to pull out of this. Remember, these PD sockets here are only 18 watts, because the highest they go is 12 volts, 1.5 amps. So 18 watts at about 4 volts. It's not a lot of current. Well, I suppose it's 4.5 amps, but this nickel strip's not going to be too concerned about 4.5 amps. No, it's not. So that's it. My L-shaped power bank with 2 PD and USB-A, and of course USB-B for charging for the input, is kind of complete. I think it looks the business. Right, nuts back into this bag. Oh, there's a rogue nickel strip there that's not been cut properly. I expect it still works. So let's charge the RAV power bank, which has PD input, which can take up to 30 watts. Of course, it's not going to get 30 watts because this is only a 18 watts. Plug it into this one and see what happens. Right, the high voltage green lights have come on. This is flashing. That means it's going the wrong way. I don't want to charge this. I wanted to charge the RAV power. So if I press and hold that for about 8 seconds, I think it was, we should be able to reboot this, and it changes direction. So now it's charging, and I'm going to use this to charge the RAV power fully. So I presume these green lights simply mean not 5 volts, so a voltage higher than 5 volts. Now this board only does 9 and 12, so I assume it's gone to 12. I don't have a device to check that yet. And we're charging this at 18 watts, is my guess. Yeah, let's just leave it there. Incidentally, I meant to say that this RAV-Power power bank has 4 cells in it, arranged. The electronics are all down this one end. The cells are arranged like this, but they're not 18650s. They're actually 21700s, and I've got one of those here. So it has 4 of these bigger 21700s, and I mean, you can see the difference in size and diameter. So yeah, that's a 21700, and they tend to be about 5000 milliamp hours. So the 4 of those all in parallel is what gives this power bank its 20,000 milliamp hour rating. But anyway, that's kind of how to build a wonderful L-shaped power bank using 1300 milliamp hour cells. Yeah, there's the 13 there. And Vrusened end caps, everything in parallel, and a couple of eBay power bank boards. Oh, that's getting quite warm now. As it would be, these inductor, it's the inductor that gets hot. I can't see the inductor now, it's in there. Oh, that's not ideal, is it? Because the heat, oh, it's not too close to the cells. It's not too bad. Yeah, the inductor's the thing that gets really warm. Yeah, these 2 PD power bank boards that you can get on eBay. You don't need to, of course, but I'll just keep those 2 there because I'm interested in playing with them and seeing how they differ in functionality. But yeah, I'm happy with my L-shaped PD power bank. Cheerio.